Welcome to Ask and Learn.
In this problem, we have a single cable, basically going on a bunch of pulleys connected to a bunch of three blocks. It's connected to one block that's sliding horizontally and two blocks that are moving vertically, and we have, let's see here, 7 pulleys. So if we just add up all the lengths of all those spans in our cable, we find that 3 times the y position of block A plus 4 times the y position of block B plus the horizontal position of block C must be a constant. Okay, so I'm taking positive to be to the right and down. If we take a time derivative of this, we get 3 times the velocity of A plus 3 times the velocity, 4 times the velocity of B plus the velocity of C is 0. And then likewise the accelerations, we can get a constraint equation for that. Now we're told that the initial velocity of block B is 0. So block B moves, let's see, block B starts from rest. Okay, so its initial velocity is 0. Block A moves with a constant acceleration of 75 millimeters per second squared. And then we're told that at 2 seconds, the velocities B and C are 480 millimeters per second downwards and 280 millimeters per second to the right. Then we want to find the accelerations first. Okay, so we have at 2 seconds, so I'll call that T1. So V at T1, VB at T1, and VC at T1 were given. Now we know that VA at any time is the acceleration of A times T plus velocity of A at T equals 0, and likewise for the velocity of B and for the velocity of C. Now we know that from the constraint equation up here at T equals 0 and also at T equals 1, we have these two equations. So the velocity, we know the velocity of B initially is 0, so that goes away and that goes away. So at T, VA1 is acceleration of A times T1 plus VA naught, and likewise for VB1 and for VC1. Now from this equation, we know VA1 here, we know T1, and we don't know, let's see here, we know, no, this from here, right, we know VC1, we know AC, and we know T1, so that gives us all these. And that tells us that VC naught must have been 130 millimeters per second. And so then we can go back up here, because we know VB naught is 0. We can get VA naught is minus 130 divided by 3 millimeters per second. Now we also know that VB at T1 is 480 millimeters per second. So we got 480 millimeters per second. VB naught was 0, so that must be the VB1 must be the acceleration of B times 2 seconds, or T1. And so that gives us the acceleration of B is 240 millimeters per second squared. And then we can go and get the acceleration of A from, let's see here. We have the acceleration of A, where you can find it from here. So we know the acceleration of C, and we know the acceleration of B, so we can find the acceleration of A, and that is minus 345 millimeters per second squared. And so we got accelerations of B and A, which was what we were asked for, and then we want to know what the change in position of block C is. So the change in position of C is 1/2 times its times the acceleration times t squared plus its initial velocity times t, and we're told that after 3 seconds, so we know t is 3 seconds. We can plug that in. We know the acceleration, which is a constant, we were given that is 75 millimeters per second squared. We know its initial velocity. We can find the initial velocity. Here's the initial velocity up here. We had that from before. And now we know everything here, and we get that it has moved 727.5 millimeters to the right